All right, today we're going to dive into something that, I gotta admit, looks incredibly dry on the surface. It's a 5-page military document from 1999. But trust me on this one, it's actually a masterclass in precision. It gives us this amazing window into how really high-stakes systems are built. So let's decode this thing together.
So, right off the bat, here's the cover. And okay, the title says Computer Programming Manual, which seems pretty straightforward, right? But then you read the fine print and you realize what this thing really is. This document doesn't teach you how to program a computer. No, it teaches you how to write the manual for one. It's literally a set of instructions for writing instructions. How wild is that? And that immediately brings up a huge question. Why? Why would you need this level of meta-documentation? Why create a super rigid 5-page standard just to tell someone what another document should look like? Well, the answer, as it turns out, tells us a whole lot about what it takes to build things that absolutely, positively cannot be allowed to fail.
Okay, so to get to that answer, we really have to understand the context here. We are not talking about the manual for your home PC or a PlayStation. Not at all. This is all about making sure there is extreme, absolute clarity in situations where the stakes are as high as they get.
And the document itself actually gives us our first huge clue. It says the manual is for newly developed computers, special-purpose computers, or other computers for which commercial or other programming manuals are not readily available. So what's that mean in plain English? Think missile guidance systems. Think special battlefield hardware, or some unique signal processor. These are one-of-a-kind machines. You can't just go Google the manual if you get stuck. The documentation has to be perfect, right from day one.
So there's actually an official term for a document like this. It's called a data item description, or a DID for short. And this is a really core concept in government and military contracting. It's basically the official rulebook that a contractor has to follow when they're delivering a specific document.
And I think this is the perfect way to think about it. A DID is basically a recipe. It's there to guarantee that whether you're building a new computer system for a tank or a ship or a jet, the manual that comes with it is baked exactly the same way every single time. It'll have the same structure, the same format, the same level of detail, no matter who the contractor is. The whole point is to just remove any and all ambiguity.
Okay, so what does this recipe actually call for? What are the ingredients? Well, it lays out a very, very specific blueprint for the programmer, and it goes section by section.
The DID mandates this really specific 6-part structure. You can see it starts broad, right? You've got identification and computer system overview. Then it drills down into the programming environment and the really specific programming information. And then it wraps up with notes and appendices. It's like a logical funnel, taking you from that big picture, 30,000-foot view all the way down to the individual nuts and bolts.
And here's why that's so crucial. Following this blueprint makes sure that nothing, absolutely nothing gets messed. A programmer who's picking this manual up for the very first time will know the machine's purpose, its hardware, what software tools they have, and exactly how to make the whole thing work.
But honestly, here's where it gets truly fascinating for me. It's not really the high-level structure that's so remarkable. It's the insane, you could almost say obsessive, level of detail that's required inside each one of those sections. So, for example, in that programming environment section, the writer has to describe things like the machine's cycle time, the word length, memory capacity and its characteristics, interrupt capabilities. I mean, we're already getting deep into the core DNA of the processor here. And believe me when I tell you, this is just scratching the surface.
Because the standard doesn't just stop at the basics. Oh, no. It forces the writer to literally dissect the system, piece by painstaking piece. It demands that we go much, much deeper. So now we're under the programming information section, and the requirements get even more granular. The manual has to detail things like instruction formats, addressing modes, how it handles interrupts and timers, memory protection features. It's basically a complete schematic of the computer's brain. And yet, if you can believe it, we're still not at the most detailed level. This is the real climax of the entire document. The DID specifies that for every single command the computer can possibly execute, we're talking every add instruction, every move instruction, every store instruction. The manual has to describe all of this. Just take a second and look at this list. For one single instruction, you have to document its use,
its syntax, what condition codes it sets, its exact execution time, its machine code format, even its mnemonic conventions, which is basically just its shorthand nickname. Everything. Now, try to imagine doing that for hundreds, maybe even thousands of individual instructions. That is the absolute definition of exhaustive detail.
So after all that, you have to ask yourself again, why go through all this trouble? What's the point? Let's zoom back out for a second to the bigger picture, and it'll all make sense why this level of standardization is so critical.
And here's the bottom line. It's actually pretty simple. When a system's failure could be catastrophic, you absolutely cannot have a programmer guessing how the hardware works. There is zero room for misinterpretation. Every single variable, every little quirk has to be known and documented. In this world, clarity isn't just a nice to have, it is a fundamental, non-negotiable mission requirement.
And that right there is the real takeaway from all of this. I mean, even though this document is from 1999, the age of dial-up modems, it teaches this totally timeless lesson. It applies to software engineering today, to aerospace, to any complex field, really. If you want to build things that last, things that are truly reliable, it doesn't matter if it's the navigation system on a spacecraft or the control software in a new EV, it requires this almost obsessive commitment to clear, unambiguous documentation. Which kind of leaves us with one final big question to think about. In today's world, with agile development and that whole move fast and break things mantra, is this level of rigid, painstaking documentation a necessary lifesaver, or is it just a roadblock that gets in the way of innovation? It's a tough one.